In this question, you've been asked for both vertical and horizontal asymptotes. And they're going to come from different parts of the graph. The horizontal asymptotes come from the limit as x approaches positive and negative infinity. So as I look at this first question, 10x minus 20 over x squared minus 4. When x is very large, the negative 20 and the 4 have very little to do with the graph. So we're looking at 10x over x squared, or 10 over x, which approaches 0. And it doesn't matter whether I plug in positive or negative infinity to that x. I'm still going to be dividing small by big. So I have one horizontal asymptote at y equals 0. And all horizontal asymptotes will be horizontal, and therefore y equals in their answer. Now we're going to look at the vertical asymptotes. Those come from when the denominator may be 0. So I'm going to factor a 10 out of the numerator and get x minus 2. And the denominator I'll factor into x minus 2 and x plus 2. And I can see that there is a common factor of x minus 2. That means there's a hole, but not a vertical asymptote. So when I remove that hole, I'm really removing the discontinuity. And I could find where that limit is, but it wouldn't tell me an asymptote. But this tells me an asymptote. When x plus 2 equals 0, I would be dividing by 0, or x would be negative 2. And this is the equation of that vertical asymptote. It's a vertical line, and all of the x values along that vertical line are negative 2. So those were the two answers: x equals negative 2 and y equals 0. Now the next portion of this question is solved in the same manner, but in this case it's going to matter which one we plug in for x, positive infinity or negative infinity. So when I plug in a positive infinity, the 4 and the 1 are inconsequential, and so I literally have the same negative 2 over big over negative 2 over big. And those cancel out exactly because they're the exact same thing, giving me 1. So one of my horizontal asymptotes is at 1. Now I'll repeat the process at the limit as x approaches negative infinity. And now the 4 and the 1 matter because I have negative 1 over 2 to the positive infinity. When I plug that negative exponent in, it turns me into a fraction. And of course this whole term is small over big and goes to 0. Similarly, I have 1 minus 1 over 2 to the infinity. This goes to 0. And so I have another horizontal asymptote at 4 over 1, or 4. And literally what I can say is that my graph is going to go to the right, going to 1, and going to the left will go to 4. And then the same process as before, I'm going to look, does the denominator of 1 minus 2 to the x, I'd have some number, does this whole term ever equal 0? Well, it does. 1 minus 2 to the x, what would make that equal 0? 0 would. Because 2 to the 0, anything to the 0 is 1, and that would give me 1 minus 1 equals 0. So I have a vertical asymptote at x equals 0. Now, if I wanted to see what the graph looked like, I would have to do the limit as x approaches 0 on the positive and the negative side, and that would tell me which way my graph looks like. It turns out that I can tell another way too. If I just look at my numerator, 4 minus 2 to the 2 would give me 0. So I know that when x is 2, I have a 0, meaning my graph must come through 0 and approach that way, come down and approach that way, because there's no more zeros over here.